Hello, welcome to our lesson on solving quadratic equations by factoring. Some updates and announcements. Don't forget that all assignments can still be submitted. If you haven't done so already, go back and complete any missing assignments from quarter 3 or from the e-learning quarter. Don't forget that e-learning is 50% of your final grade, so if you don't do it at all, you will fail the semester. So make sure that you're working on your e-learning for all your classes. You need to be using your Riverside email address in order to access the IP. That email is firstname.lastname@riversidehighschool.org. If you're not using that email and don't know how, please email me and I can help you set that up. It makes it much easier for me to email you and contact you when I'm trying to get in touch with you about something. Office hours are held Monday through Thursday from 11 to 12. The link can be found at the top of the Haiku page. If you need more one-on-one help, don't be afraid to reach out. I've got plenty of time to get together with you. Email me and we can get together for a private office hour. Struggles or celebrations. My struggle this week is that many students are not bothering to watch the video or take notes and then getting low scores on the IP. These assignments are not meant to be done without watching the lesson first. Great job to those of you who have been watching the video and taking notes. I promise it's helping you get better scores. My celebration is that more students have been emailing me about what they should do to get caught up. Shout out to Terry Alexander, Kanye Shelton, and Janiyah Thomas for emailing me first thing this morning about things they could do to improve their scores or to make up their missing work. Keep up the good work. Before we start, don't forget that you should be completing lessons in order. If you've not yet done previous e-learning assignments, you should go back and do those first. For example, today we're going to be using factoring quite a bit, and if you're struggling with the factoring, you should go back and redo those lessons. Make sure to take notes while you complete your assignment. If you don't have a paper and pencil out now, pause the video and go get some. When the video says to pause and try the problems on your own, do it. The way our brain works is that we need to be able to practice things in a way that we can learn from our mistakes. And so if you're trying these on your own and then I'm going over it with you, you'll do better than if you were just trying these on your own for the first time on the IP. If you're still unhappy with your grade after you submit your assignment, just email me for help and resubmit for a better grade. Don't forget we can get together on office hours and look at the ones you missed and you can redo those. Right now, pause the video and complete the bell work below. Remember, it's really important to keep practicing these problems so that you don't forget everything while we are gone. I'll go over solutions if you get stuck. Go ahead and pause the video and try these now. All right, the directions say to factor. That's where we are breaking our trinomial into two things or three things that could be multiplied together. Remember, we're supposed to start by identifying our A, our B, and our C. So A is 1, B is 2, and C is negative 24. The trinomial, I have to have 4 terms to be able to factor, so I'm going to start with my ABC tree. I'm going to multiply A times C, that gives me negative 24. I'm looking for two numbers that multiply to be negative 24 and add to be 2. If you don't know, you go through the whole list. 1 times 24, no. 2 times 12, no. 3 times 8, no. 4 and 6 might work because they're 2 apart. If I need a negative 24, only one of these can be negative. I need a positive 2, so the larger number has to be positive. So my magic numbers are negative 4 and 6. Now I'm rewriting my trinomial. So here's the original trinomial. I am replacing B with the magic numbers. Remember, that's why I wanted them to add to be 2. So this becomes m squared. I like to put the negative number first. It makes the calculations easier. Plus 6m minus 24. I'm looking for the GCF of the first two. M squared and 4m can both be divided by m. I had 2, I took away 1, so that leaves me with 1. And so that's m minus 4. Negative 24 are both divisible by 6. 6m divided by 6 is 1m. Negative 24 divided by 6 is negative. I did this correctly because the two binomials match, so this becomes m minus 4, and then what's left is m plus 6. Good job. Now this last one did not have a GCF, but this one does. Let's think about what 2, 6, and 108 are all divisible by. Well, they're all divisible by 2. So if I divide everything by 2, that becomes minus 54. That's my new A, B, and C, not the 2, the 6, and the negative 108. I also don't want to forget that 2 is a 2 in my answer. Now I'm going to do the same thing I did on the first problem. I'm going to multiply for two numbers that multiply to be 54 but add to be 3. 1 and 54, no. 2 and 27, no. Looks like maybe 6 times 9 might work because they could be 3 apart. I need the larger number to be positive so that I get a positive 3, so that means that must be a negative 6. So my new trinomial becomes m squared minus 6m plus 9m, and don't forget, I changed c, it's not 108, it's minus 54. Break it up into two groups. The first group has a GCF of m, so that's m minus 6. The second group has a GCF of 9, so that's m minus 6. And so I'm left with m plus 9 times m minus 6. Don't forget I had my original 2 here, so that's minus 6. Good job. Our lesson for today is called Solving Quadratic Equations by Factoring. By the end of this lesson, you need to be able to solve. That means we'll be able to figure out what x is equal to. If you really struggled with that last spell work, if you do not know how to factor, you need to stop this video and watch the factor review video for Monday and Tuesday. I'm not going to continue to just reteach factoring in every single video, so you need to go back and utilize those resources yourself. So when we want to solve a quadratic equation, solve instead. What we have been doing is factoring. Now we're going to be solving using factoring. We want to write our equation in standard form. We're going to talk about what that is in just a second. We're going to factor the quadratic, and we're going to use the zero product property to find the zeros. So here's what we're actually doing, guys. When I find the zeros, sorry, my coordinate plane is going to be a little crooked on this. What I'm finding is where my curve crosses the x-axis. So let's say that I know these are my zeros. That means my curve crosses through those 2 points like that. Again, if I knew that my zeros were here and here, that means my curve crosses through those zeros. So that's what I'm finding when I find the zeros. All right, in your notes, be ready to write. Standard form looks like this. ax squared plus bx plus c equals 0. A, b, and c are, we don't want to say constant values there. We want to say integers. Integers. They are constants, but they're also integers. Standard form tells us that one side of the equation must be equal to 0 before it can be solved using factoring. For example, this equation is in standard form because it's equal to 0. It's got the x squared first, the 9x second, and the constant third. However, x squared minus 5x equal to negative 3 is not in standard form because the quadratic is not equal to 0. It's equal to negative 3. You cannot solve using standard form, which means we got to make this equal to 0. So that's going to be our first task. So let's start with just some quick, is this in standard form or is this not? So example 1, is this quadratic equation in standard form? We'll look back at your notes. Remember, standard form looks like this. ax squared plus bx plus c equals 0. This has a number with the x squared plus a number with an x minus a number by itself equal to 0. So we would say yes, because the quadratic is, and I'm going to do a shortcut here, is equal to 0. Now for this one, is this in standard form? Definitely not. The quadratic is not equal to 0. All right, pause the video and try example 3 and 4 on your own now. So for example 3, was this in standard form? We would say yes, because the quadratic is equal to 0. For this one, we would say no, because the quadratic is not equal to. So equal to 0 is really important because we have a property that's going to use that 0 here in a little bit. If it's not equal to 0, then you can't use the zero product property. All right, so we agreed that 5x squared minus x equal to 4 and x squared minus 2x equal to negative 7 were not in standard form because the quadratic equation was not equal to 0. Therefore, we need to write quadratic equations like these in standard form before we can solve them by factoring. So remember, our goal is to get the quadratic equation equal to 0. So I have 5x squared minus x equals 4. What I need is a 0 over here. So if I want a 0, then I need to subtract 4 from each side. Remember, I can only add and subtract things that are like terms. I can't actually subtract 4 from 5x squared or x, so I just write it together. And that's where we get our standard form. We've got a number with an x squared, a number with an x minus a constant is equal to 0. You should have written to do that now. Example 2, again, we need this to be equal to 0. This time it's a -7, so we're going to add 7 to each side. So again, we can only add and subtract things that are like terms. 7 is not alike with x squared or 2x, so we just write that as x squared minus 2x plus 7 equals 0. Pause the video now and try example 3 on your own. Equal to 0, that's a positive 13, so we're going to make it equal to 0 by subtracting 13 from each side. So we have m squared plus 2m minus 13 equals 0. Nice job. All right, zero product property. In order to find the solution equation, we must use the zero product property. The zero product property says this. Two terms are multiplied, excuse me, that should say factors. Two factors are multiplied to make 0. Either one or both terms should equal to 0. So if I know that 4 times x equals 0, then I know that x has to equal 0. If I have x times y equal to 0, I know that if x was 0, the whole thing would be 0, and I know if y was 0, the whole thing would be 0. So I want you to notice that I was able to split this up into two separate problems. I had two things multiplied to give me 0, and so I split it up into two problems. That's what we are going to be doing today. Notice that these are already won't always be like that. So we want to notice that we have two factors being multiplied together to give 0. I'm going to use that zero product property to split this up into two pieces. It could be equal to 0, or a plus 2 could be equal to 0. Either way would make both of these zeros. We're going to subtract 1 from each side, so a becomes -1. We're going to subtract 2 from each side, so a becomes -1. Notice that we have two answers. What I've just found are the x-intercepts of my curve. If I was going to graph this, that's where the curve would cross the x-axis at -1 and -2. All right, pause the video. Use example 1 to help you. You try example 2 in your notes right now. Welcome back. You should have noticed that you had two factors multiplied together. So you do k plus 1 equals 0, k plus 5 to each side, so k equals 5. So your two zeros are -1 and 5. Let's try two factors being multiplied together to give 0. That tells me I'm ready to use the zero product property. Or k plus 1 could be equal to 0. Sorry, my pen's a little slow. We're going to subtract 5 from each side. So 4k, divide both sides by 4. And so, sorry, we ran out of room there. That's k equals -5/4. For this one, you should have just subtracted 1 from each side. And so k has to be equal to -1. Go ahead and pause the video now and try example 4 all on your own. You should have done 6c plus 7 1 equals 0. We're going to solve both of those. We're going to subtract 7 from each side. So 6c divides by 6, and c ends up being a fraction, -7/6. For this one, we're going to add 1 to each side. So c is 1. So my two zeros are -7/6. All right, we're going to pause the video here. You're going to go back to Haiku and look at video part 2. By the way, the reason why I make these in two parts is because I can only do 15 minutes at a time uploaded to YouTube. See you soon.